Guys, we got cut off during class the other day, so I wanted to make sure that I got you the notes that we kind of missed there at the end of class. I think we got cut off right as we were starting this first example. And so I want to do 2 or 3 of these examples of absolute value inequalities. That way you have the notes that you need to make sure you get your homework finished correctly. So if you have these notes from the notes packet I gave you in class, get those out. If you're someone else joining us for this video, feel free to copy these down. So let's go ahead and get started with the first one. This is the one we started during class, and I think I literally got cut off like right as we were starting it. So let's just start it over from the beginning. Remember, we treat inequalities just like equations, and I know it seems silly for some of you still, but draw the line, and I'm going to first isolate this absolute value. So remember, our first step is to isolate. So to isolate that, I'm going to subtract 2, and that leaves me with the absolute value of 3 minus x. And I have 12 on this side, and since I didn't multiply or divide by a negative, we keep our sign the same. Then this comes to where we split up the problem. So just like I do with equations, I'm going to split up the problem. 3 minus x equals 12, except it's not equals, it's less than or equal to. So that's the first one. The second one looks similar. Okay, 3 minus x, remember we have an opposite. This either is equal to 12 or equal to negative 12. But since it's a less than sign, I actually, when I put the negative here, I flip the order around. So what that's saying is whatever is inside this absolute value, since I want the distance from 0 to be less than 12, I either want this number to be less than 12, I also need the negative values to be greater than negative 12. And since it's less, I'm going toward 0, I'm staying close to 0, I split it with an and. Then we solve both of these two parts separately. So I'm going to subtract 3, and then I'm going to actually get rid of that negative at the same time. So x is, because there's a negative here, I'm going to flip my sign. 12 minus 3, and then I'm going to change that to a negative. For the negative, I'm getting rid of. And minus 3 again. To get rid of this negative, I flip my sign. I'm going to get rid of the negative here also. So then if I need to graph this, right now I'm just solving, but if I wanted to graph, I could graph that. X is greater than negative 9 and x is less than 15. So there's my negative 9, there's my 15, and I'm graphing everything between them, including negative 9 and 15. In interval notation, I would write this bracket, negative 9, comma, 15, with another bracket on the other side. That box is kind of small, so hopefully you can follow me through the colors there. So then if I have something like I have here, for example, 2, where my absolute value here is kind of buried in some other stuff, the process is still the same. I'm going to start by isolating my absolute value. I'm going to subtract 9, and I'm going to divide by negative 2. So absolute value of a plus 4 is less than, I caught myself, I divided by a negative, so greater than or equal to. Negative 5 minus 9 is negative 14, divided by negative 2, 7. So my absolute value is greater than or equal to 7. The distance from 0 is greater than or equal to 7. So the number in here is either a positive number that is greater than 7, or it's a negative number that is less than or equal to negative 7. So on the positive side, I have greater than 7. The negative side, I have less than or equal to negative 7. Those are the numbers that have a distance from 0 that is further or equal to 7. So it's 7 or greater distance from 0. And then I solve both of those. Easy here, just minus 4 everywhere. A is greater than or equal to 3, or A is less than or equal to negative 11. And then I can graph that. Once we get that part, the graphing here shouldn't be too hard. Right, we talked about how to do these before. Greater than, I did those numbers backwards. Let's try that again. You know I get crazy sometimes. Negative 11 and 3, there we go. Greater than or equal to 3, or less than or equal to negative 11. And again, let me get my blue pen here. In interval notation, negative infinity to negative 11, bracket, with the U for union of the two sets, bracket, 3, comma, infinity with a parenthesis. So there's our interval notation. All right, let's try another one. I'm gonna scroll down here. The next two are our special cases. So if I look at the next two, we're going to talk about the special cases we have. So if I look here at the first one, example 3, I have absolute value, it's already isolated, and it's less than negative 2. When is an absolute value less than a negative? So when is a positive less than a negative? And that's going to happen never, right? Positives are always bigger than negatives. So this has no solution. There's never going to be a time when my positive is less than my negative, okay? Not going to happen. The second one here, I have absolute value is greater than a negative. And again, if you should always kind of stop and think that there's something going on when you have a negative on the other side of that absolute value. It should always trigger something in your head. When it's an equal sign, it's a no solution because it can't be negative. However, in this case, with it greater than, the question is when is a positive greater than a negative? And that's going to be always. And so our solution set is all real numbers. Or you can write it negative infinity to infinity. Seems kind of silly to write that out, but that's our answer. It can be anything I want can be plugged in here. It's always going to be greater than negative 5. Okay? So that's a quick and short, our two special cases with absolute value. All right, let's try this number 5. So we'll do one more example here, number 5. Number 5 here, I'm going to start by isolating this absolute value. Absolute value of 2x plus 3 is greater than 5. So I want to know when 2x plus 3 has a distance from 0 that's more than 5. So those are when 2x plus 3, when that value is a number greater than 5 on the positive side. Or on my negative side, when 2x plus 3 is less than negative 5. Those distances from 0 are going to be 5 and more away from 0. Okay. And then just like before, we solve each of those inequalities. I just like to do them at the same time, so I usually do it that way. And I put my or back in between. And now I have my answer. I'm going to graph it. X is greater than 1 or x is less than negative 4. Open circles this time because I'm not equal to. And then my interval notation again, negative infinity to negative 4, parenthesis, u parenthesis, 1, comma, infinity. Remember, always put them in order, least to greatest, as far as what's on your number line. Okay? I think that's it. That should be all the examples that you need in order to complete your homework, in order to continue doing these absolute value inequalities. Please let me know if you have questions. Otherwise, you should be able to finish up that homework that we assigned, even though we didn't get to the examples. So, all right. See you guys later.